Well, when it comes to the P series, the first thing I want you to be able to identify is its structure. For this one, here's how it looks like. So firstly, it's a sum as well. And the first difference that you observe as in compared to the geometric series is that unlike the geometric series, the P series starts from an n is equals to 1 and then also goes all the way up to infinity. And this is for 1 over n to the power p. Again, compared to the geometric series, this was infinity, this was starting from 0, and what we had was a r to the power n. What you notice here is, for the P series, it's the base that is changing, and the power is a constant value. But for the P series, the base is a constant value, and the power of that base is what is changing. So this is for the geometric series. The base is constant, the power is what is changing with that summation. In the P series, the base is what is changing, the power is what is constant. So this is one key difference. And apart from that, you notice that the P series deals with the n term being in the denominator. But here, this actually works with everything being considered as terms in the numerator. Okay. Otherwise, the two are pretty much similar. And one other difference that you perhaps notice is in the way you conclude whether the series diverges or converges. When we looked at the geometric series, we say that if the value of r was greater or equals to 1, then we'd conclude that this diverges. And if it was in the range from 0 less than 1, not less than 1, 0 less than our r term less than 1, then would conclude that this converges. But what we want to observe here is that for the P series, it kind of switches them up. Firstly, when you have P being greater than 1, that is when it will actually converge. See that? This is P greater, not greater or equal to, just greater. And for it to diverge, now you need P to be in the range 0 less than P, but now less or equal to 1. Then it will diverge. So I just thought I compare them for you like this so that you can see how they work. Now, with that in mind, how does it work from here? Well, from here, if you were to expand that sequence just a little bit, what you'd have is the sum up to infinity from n is equals to 1 of 1 over, then you have n to the power p. The first few terms, what you'd have is when n is 1, you have 1 over 1 to the power p, which is still just 1, plus when n is 2, you have 1 over 2 to the power p, and then when n is 3, you have 1 over 3 to the power p, and 1 over 4 to the power p, and so on. Now, if p was equals to 1 here, if let's say p was equals to 1, then this term would get, or this sequence would get a special name. So if p was equals to 1, then not the geometric series, the P series is now called the harmonic series. So this is a special form of the P series where p is equals to 1. Now, since we are saying for the harmonic series p is equals to 1, clearly, when you compare it with whether it diverges, is to conclude whether it diverges or converges, all we need is to know what p is. For the harmonic series, p clearly is equal to 1, meaning it falls in this range, implying that the harmonic series diverges. Okay, so any questions on that? Okay, I didn't get anything, so and I assume we are okay there.
Maybe you can come again.
Okay. So what I mentioned here was, or what I was trying to say here is the P series expands like this. And the values of P here can be anything. P is a real number. So P is not just a real number, let me say a positive real number in this case. But if P was to be equals to 1, if you had an expression where P is equals to 1, meaning you're dealing with the sum from n is equals to 1, but this is just for 1 over n, meaning it's n to the power 1. If you had such a case, how would the sequence look like? This would be 1 over 1, and then this would be 1, that's a sum, so let's go plus 1 over 2 to the power 1, which is still just 2, then plus 1 over 3 to the power 1, which is still just 3, plus 1 over 4, plus 1 over 5. It keeps going up until 1 over n. Just keeps going. In this case, you're seeing that the value of P is just 1. Now, firstly, this kind of series, it's a special form and it's called a harmonic series. So the harmonic series is just this. It's just a P series, but it's a P series where P is equals to 1. So if they say determine whether the harmonic series or state whether the harmonic series diverges or converges, you are starting with a P series expression, but you're setting a P to be equals to 1. Now, if you wanted to conclude whether this series diverges or converges, then you'd have to go back and look at the condition for convergency here. For the P series, to determine whether it converges or diverges, the value of P has to satisfy a certain condition. To converge, P has to be greater than 1, not greater or equal, greater. But for the harmonic series, P is equal to 1. It's not greater than 1. So meaning it doesn't converge. But does it diverge? We come back to what qualifies something to diverge for the P series. To diverge, the value of P has to be in the range from 0, not included, all the way up to 1, included. So here we clearly see that the P series, the value of P for the harmonic series actually falls in this range. For the harmonic series, P is equals to 1, and 1 is included in this range, implying that the harmonic series diverges. Have you got that now?
Yes, sir. Yes.
Okay. Okay. So this is how we play with the P series. Okay. Can we look at an example? I think for the P series, for the most part, the things that we find here are pretty basic. We've seen the harmonic series as well already. We've discussed whether it converges or it diverges. Can we find interesting questions from your tutorial sheet for us to look at? Let's try to check. Okay. One thing that we did not mention when we talked about the geometric series earlier on was about when it converges, what does it converge to?